Hi guys, welcome to today's lesson. So right now we are going to focus on exploring different functions, right? So we're going to actually look at functions on their individuality and try to see what each function composes of and what are the key ideas whenever you're looking at those functions. But before, let's just look at the mapping of everything that has to do with functions that we are looking at. So remember, the big idea here is functions, and there's different types of them, which is what we're actually going to look at, each type of function. The definition, the main thing here for this lesson is what you call a turning point and an asymptote as to what exactly do these things mean and how to go about understanding them. Now, as I said, the key word here is the turning point. Firstly, the first type of function we're going to look at is the quadratic function, which is a function of the form y is equals to ax squared plus q. Now, so the a and the q are normally constants. Remember, every function needs to be drawn on a Cartesian plane which has x and y. So that's why the y and the x are always there. You don't change them. But what we don't need is the a and the q. So that's why I'm saying these are constants, meaning they are actual values, right? So a can be any real number, q can be any real number. And then the graph of a quadratic function is normally called a parabola, right? So this is called a parabola, which we will look at the shape of it just now. Firstly, I want you to consider the graph of f of x is equals to x squared. Remember, the f of x is my output values. This is the output, and the x value will be the input value, right? So that's why I only give you the x values. I want you to find the f of x. So when x is minus 2, the value of f of x is going to be minus 2 all squared, which will give me a positive 4. When x is minus 1, it will be negative 1 all squared, which will give me positive 1. When it's 0, it will be 0 squared, which is equals to 0. And then 1, it will be 1 all squared is equals to 1. And then when it's 2, it will be 2 squared is equals to 4. Now, just to make a note about this as well, I know even sometimes we think we only need brackets when it's a negative value, but just so that you get used to it, please include brackets, whether it's negative or positive that you are substituting. Just use brackets at all times, so that even when you have forgotten that you must use brackets, it is just conditioned to you that whether it's positive or negative, I must have brackets. So you won't suffer from these things of making these clumsy mistakes that we make, where if it's a negative and then someone does not include brackets, it won't give you a positive answer in terms of when you press a calculate, right? So what I really mean is, if you say minus 2 squared and press this on your calculator, I promise you, it will not give you a positive 4. It will give you a negative 4, which is something different from what we need to look at. So please, this you must not do at all times. You must make sure that you include your brackets. Now, the graph is normally obtained by plotting the points on a Cartesian plane and drawing a curve through those particular points. Remember our points, this is supposed to be 4 there, just not 1. So if that is 4, that is 1, that is 0, 1, and 4. It means, firstly, I will start with minus 2. From minus 2, you know it's 0. You move 2 units to the left. At minus 2, you move 4 units up. So it will land you at this particular point there. And then minus 1, you move 1 unit up. It will land you at that point. 0 with 0, 1 with a positive 1, 2 with a positive 4. And then you just join these points like this. right? So you just join them, and then it will give you a curve like that, right? So at the end, we normally indicate the end of the graph with an arrow to show that this is actually going to continue indefinitely. We just used few values here, not all of them, right? Because remember, a number line continues up until positive and negative infinity. If you draw it up to scale, it will look like this, which is more or less the same as what I just showed you now. Now, all output values are positive. Why are they positive? Because of the squared that I have there. So you can see all the output values is positive. 1 is 0, 2 there if I want to use it, 3 there, and there's a 4 there, and then you know there will be a 5 there. So all the output values will all be positive. And then the graph, we call it a parabola. So this is called a parabola, right? So you need to, why we call it this is because we're not going to be using the word quadratic function going forward. It will be draw the following parabola or analyze the following parabola. So that's the word we are going to be using going forward. Now, the domain of the graph is normally given by x is an element of real numbers. Why I'm saying this is because the x squared makes it a point that all the x values that are on a number line, because they are real values, they are all defined, they are all valid on this particular graph, right? So that's why the domain will be x is an element of real numbers. Remember, domain is a set of all the input values where the graph is defined. So it means on the number line of the x-axis, whether you go to positive infinity or negative infinity, all the numbers are defined. They are all valid. But with a range, we then need to limit this, right? Remember we said all the output values are positive. So it means all the output values are, number 1, greater than the 0, meaning they are positive. Number 2, they also include the 0 itself. So I will say the range is y is greater or equal to 0. This simply means that 0 is part of the y values, and then anything else that is positive will also be part of the y values. Now, also, I know that maybe some of us, it might be the first time we're seeing the letter element of. Element of would just mean a set of all these values that are there. And then this is also normally written as y is an element of. Remember, we said 0 is part of this, so I will have 0 there, a semicolon, and then I say this is to infinity. And then you leave it like that. Why this is a square bracket is because 0 is part of the answers. You always start with a small number and go to the biggest number. And the biggest number here is infinity, which we do not know. Now, when you talk about the shape of a parabola, the value of a, right, in this equation, the general equation, determines the closeness of the arms of the parabola to the y-axis. So you do need to understand this, right? So it means if a maybe is small, it will be this particular close, and then if it's big, you'll find that it's a bit wider like that, right, from the y-axis. I know I'm not drawing it to scale, but it gives you an idea of what we really mean. The larger the value, the closer the arms are to the y-axis. So if it's 2x squared compared to 4x squared, this will be a bit wider and this will be a bit close. So this will be maybe something of this nature, and then if it's 4, it will be a bit closer now to the y-axis. So the arms will be a bit close to the y-axis. And then the sign of A will cause what we call a reflection in the x-axis. Now, we normally use the word happy face and sad face, right? And I will show you why we say that. If A is a positive, the parabola is called a concave up, which we say is a happy face. Why it's a happy face? It's because it is forming a smile, right? So it's a curve that is facing up like this. So it is forming a smile, which is a happy face. So that's why we are saying it's a happy face, just for you to understand and see it visually with your eyes, right? Then, when it is less than 0, it is normally said to be concave down, which we say is a sad face, right? So it will be facing that way. Now, we also have what we call the turning point, right? The turning point is where the graph is going to change direction, right? So it is where it is going to turn, as the word itself says, turning point. It means that it's where, so the graph will go, it will get somewhere where it curves a bit, and then it changes direction, and now it goes up like that. So the turning point will be where it is just turning to change the direction. Normally when A is positive, meaning greater than 0, the turning point is normally said to be the minimum, and then when it is concave down, which is a sad face, the turning point is said to be a maximum, because that's the highest point of the graph. Guys, I hope you are enjoying this as much as I am. But for now, I want us to take a quick ad break. When we come back, we'll look at one other function and see what it is all about. Please stay tuned.